So here's a problem I'd like you to try to solve on your own. Okay, it's kind of the problems that's the opposite of the last problem that came at the end of the previous video. So the previous video we were given the equation of a line in the form ax plus by plus c equals 0, and we had to put it in vector form. Now we're given the equation of a line in vector form, and we're going to want to write it as an equation involving x and y. So that's a number 2, but in number 1 we'll first start by something much simpler. I want you, with using the vector form of the line, which is this, okay, I want you to find 2 points on this line. Okay, so pause the video and find me 2 points. Okay, so this vector form, it's basically a formula to give us that gives us like infinitely many points by assigning any values that we like to lambda. Okay, so what I suggest to get 2 points is to be to choose simple values for lambda. So for example, if lambda equals 0, you're going to get a point. Then xy, what's that going to be? Replace lambda by 0, you get 4, 2. So that's a point on the line. And maybe after that, let's choose some simple value for lambda. Let's say 1, for example. Then xy is going to be 10, 1. And that's the second point. But you get the idea. If you assign lambda another value and lambda another value, you're going to get infinitely many points. So this is how this equation generates all the points that belong to this line. Okay, now here's a more difficult but not so difficult question. You want to write the equation of the line that's given in vector form above in point normal form. And I'm just reminding you what point normal form means. It means you're going to write it in this form, right? And why is it point normal form? Because x0 y0 is going to be a point on the line. Okay, so if this is your line, that's going to be one of the points on the line, and n, which is the vector that's perpendicular to the line, or a vector that's perpendicular to the line, because there are infinitely many. Okay, that's its coordinates a, b are going to be the coefficients of each term, okay, that we see in the equation a, b. So basically, to write the equation in point normal form, you need to find a point on the line. That's easy because you did that in 1. You actually found 2. And then you need to find a vector that is perpendicular to the line. So try to solve this problem and come back. So of course, a possible point is 4, 2. 4, 2, that's when lambda equals to 0. Okay, so we've got a point, but I could have chosen 10, 1. Doesn't matter. Okay, now since I need to find a vector that's perpendicular to the line, but for that, what I'm going to do is I'm going to find a vector that's parallel to the line, because that's what the vector form of the line gives me. How's that? Well, remember, now any point xy in the line is given by this, right? This vector form. I can split that up into 2 parts, right? This is 4, 2, so that's actually a point on the line, plus lambda. Well, okay, let's do it slowly because I always get questions about this. So this is 6 lambda minus I'm gonna make this right, minus lambda, like this. In this, I can factor out a lambda and write it like that. And this turns out to be my v being the vector that's parallel to the line, because that basically says start at 4, 2 and move in a direction that's parallel to v, because I'm adding lambda v. Lambda v makes it perpendicular. Okay, it makes the makes us go in a direction that's parallel to the line, right? So when we have xy, any point xy, we go first to x0, y0, so that's our 4-2, that's kind of like our x0, y0, and then we add a multiple of v. So that's, if we want to get, let's say here, this is going to be a multiple of v. So if to x0, y0 we add a multiple of v, we're going to end up here. So we're going to end up with a point on the line. So v is 6 minus 1. How do I get n? N is any vector that's perpendicular to v. So since v equals, well, maybe 6 minus 1 is parallel to the line, then n equals, I could choose 1 minus 6, for example, because it makes a dot product with v, a dot product of 0. Remember, if in R2, that only works in R2, but if I want to have a vector that's perpendicular to another vector, you just switch around the coordinates and you hit one with a negative sign. So actually I didn't do, did I do this right? I didn't do this right. So if, let's say I hit this one with a negative sign, then it makes it 1, 6. So 1, 6. And I can check if I do v dot product n, I get 6 times 1 minus 1 times 6, I get 0. Okay. So, so therefore, the point normal form of the line is, so I just need to plug in the numbers, it's a, so 1 times x minus x0, what's x0 again? It's 4, plus b being 6 times y minus y0, y0 is 2, like this, and I've got my equation in point normal form. If I expand this, I would be able to write it in the form ax plus by plus c equals 0, for instance. So that would give me what? Give me this. Actually made a small mistake. It's plus 6y right there. Okay, but what I was asking to write was just this. Okay, so that's the problem we had to solve. Now, if I look at lines in, because the topic was lines in Rn, in R3, R4, the only difference is that, for example, in R3, you're going to have a third component. So if you have x, y, and z now, they're going to be equal to a point, let's say a point 1, 2, 3, plus a direction that's parallel to the line, and we need to move parallel to that direction in order to get to another point on the line, and that would be the vector form of a line in R3. So usually lines in R3 and R4 are going to be always given in vector form. There's so the point normal form that we have for lines in R2, well, you will see that it doesn't quite exist for lines in R3 and R4. So and so on. So we're gonna only have lines expressed this way in R3 and R4. There's another way to write down the equation of lines in R3 and R4, and I don't want to talk about it. Maybe a quick question here is maybe to find another point on the line. Maybe find 3 points on the line. Find 3 points on the line above. How would you do that? Well, all you have to do is assign some values to lambda, your favorite values. I don't know, those could be your favorite values. Of course, when you set lambda to 0, you get this point. So 1, 2, 3 immediately, you know it's a point on the line. And by the way, well, let's come back to it afterwards, but we're going to talk about what's 3, 4, 5. So if lambda is 0, you get what? 1, 2, 3. If lambda is 1, you get 4, 6, 8. If lambda is -1, you get -2, 2 minus 4 minus 2, 3 minus 5, minus 2. So that's another point on the line, and you could get infinitely many points. And maybe another one, find a vector parallel to the line. Okay, how do I do that? Well, that's the other part. That's 3, 4, 5. So the coefficients of lambda in the equation, okay, coefficients of lambda, what I mean by that is if you write it like this, right, you get 1 plus 3 lambda, 2 plus 4 lambda, 3 plus 5 lambda. So sometimes in the book it's given like that. They don't split it up into two parts. You can do that to split it up into two parts, but and you can see that the coefficients of lambda, which are 3, 4, 5, that always gives you a vector that's parallel to the line. Okay, so in the next video we're going to try to generalize the equation of a line in R2 that we wrote in point normal form to R3, and we're going to see that we're not going to get lines anymore. Okay, so I'm going to pause here, and we're going to come back to cover that next topic.